Hello guys, we want to start our 15th lecture. In this lecture, I want to talk about convolution, and then we talk about convolution theorem, and at the end, so we're going to talk about inverse form of convolution integral and how we can use this theorem to find Laplace inverse of different functions. First of all, we have to define convolution. If functions of ft and gt are piecewise continuous on the interval 0 to infinity, then the convolution of ft and gt, denoted by integral the integral of f alpha gt minus alpha d alpha, the integral is from 0 to t. In fact, we show convolution of f and t by f star. We can show convolution of f and g by f star g, and it's defined as the integral from 0 to t f alpha gt minus alpha d alpha. So if you look at your textbook, so it has different notation. So it says that convolution of f and g is equal to the integral from 0 to t f tau g t minus tau d tau. So it doesn't matter if you use this notation or the notation that I use alpha because sometimes you mix up t by tau, so it's better to use alpha and t. The property of convolution is that Laplace convolution of f and g, or f star g, is equal to g star f. As a result, it's equal to the integral from 0 to t g tau f t minus tau d tau, or g alpha f t minus alpha d alpha. So it's convolution of two functions. Now, inverse of convolution theorem. So if ft and gt are piecewise continuous on the interval 0 to infinity and of exponential order, then Laplace transform of f star g, or convolution of f and g, is equal to Laplace transform of f times Laplace transform of g, or equal to fs times gs. So you have to know that it's Laplace transform of f star g. It's not like you have, for example, ft times gt. If you have just product of two functions, it's not equal to Laplace transform of ft times Laplace transform of gt. So just Laplace transform of convolution of f and g is equal to fs times gs. The other thing that is very important, so you have to know that Laplace transform of ft over gt, it's not equal to fs over gs, or it's not equal to Laplace transform of ft over Laplace transform of gt in general. So we can use the convolution theorem to find Laplace transform of some functions, or Laplace inverse of some functions. For example, let's solve one example. So at first we have to know inverse form of convolution integral. So based on inverse of convolution, Laplace inverse of fs times gs is equal to convolution of f and g, or is equal to f star g. Now we solve one example using convolution integral. So we want to find Laplace inverse of 3s over, you want to find Laplace inverse of 3s over s squared plus 1 squared. So I can say, first of all, you can easily find this Laplace inverse using partial fraction decomposition, but I want to use inverse form of convolution integral. So I can say this fraction is equal to product of s over s squared plus 1 times 3 over s squared plus 1. So 3 times s is 3s. S squared plus 1 times s squared plus 1 is s squared plus 1 squared. So it's equal to, so here is Laplace inverse. So it's equal to, if I want to simplify it, it's Laplace inverse of fs times gs. So now we have Laplace inverse of fs times gs based on inverse form of convolution integral is equal to f star g. So first of all, we have to find f and g. Ft is equal to Laplace inverse of fs. It's equal to Laplace inverse of fs is s over s squared plus 1. So it's equal to cosine t. Gt it's equal to Laplace inverse of gs. It's equal to Laplace inverse of gs is 3 over s squared plus 1. So it's equal to 3 sine t. So now we have ft and gt. So based on inverse of convolution integral, we have Laplace inverse of fs gs that we had here. So it's equal to f star g. It's equal to, based on definition of convolution integral, the integral from 0 to t, f alpha. Ft is equal to cosine t. As a result, f alpha is cosine alpha times gt minus alpha. Let me write the definition of convolution integral. So we had it in the past. So we had in the last slide. So f star g is equal to the integral from 0 to t, f alpha gt minus alpha d alpha. So ft is equal to cosine t. As a result, f alpha is cosine alpha. Gt minus alpha, so it's 3 times sine t minus alpha d alpha. So if we can find this integral, it's gonna be Laplace inverse of our function. So if you look at the formula sheet, you can see the trigonometric equations. So sine a times cosine b, so it's equal to half sine a plus b plus sine a minus b. As a result, cosine alpha sine t minus alpha is equal to sine a plus b, alpha plus t minus alpha is sine t, plus sine a minus b. So it's alpha minus t minus alpha. So it's going to be 2 alpha minus t, and it's divided by 2. As a result, Laplace inverse of fs times gs, it's equal to the integral from 0 to t. So we have 3 times cosine alpha times sine t minus alpha. So I just take 3 out of the integral. Cosine alpha times sine t minus alpha, we already found it. It's half sine t plus sine 2 alpha minus t dt. Sorry, d alpha. So it's equal to 3 over 2, the integrals from 0 to t sine t d alpha, plus 3 over 2, the integral from 0 to t sine 2 alpha minus t d alpha. Now we have to find integral of sine t d alpha. In fact, in this integral, variable of integral is alpha, but in sine t, the variable is t. As a result, we can consider sine t as a constant, and I can bring it out of the integral. So it's 3 over 2 sine t, the integral from 0 to t d alpha. Let me just give you a note here to clarify why I can bring sine t out of the alpha. Imagine if you have the integral of dx, x dx. The integral of x dx is equal to half x squared. Why? Because variable of integral is x and function is function of x. But imagine you want to find the integral of x dy. So variable of integration is y, but function is not function of y. As a result, I can say x is a constant. I can bring it out the integral. So you have x integral dy. So it's equal to xy. It's just a note to see why I could bring sine t out, because sine t is not function of alpha, but variable of integration is alpha. So plus 3 over 2. What's integral of sine 2 alpha minus t d alpha? So here variable of integration is alpha. It's minus 1 over 2 cosine 2 alpha minus t. And I have to apply lower limit and upper limit. So I just erase this part, the note, to continue the solution here. I made a mistake here, so it's 0 to, the limit of integral is 0 to t. So it's equal to 3 over 2 sine t, integral of d alpha is alpha between 0 to 1, minus 3 over 4. So I have to apply upper limit. Upper limit is cosine 2 alpha, so it's going to be cosine 2t minus t. It's going to be cosine t. And if I apply lower limit 0, it's going to be 2 times 0 is 0 minus cosine minus t. So you know that cosine minus t is equal to cosine t. As a result, this term is equal to 0. Why? Because cosine minus t is equal to cosine t. So we have cosine t here. Cosine t minus cosine t is equal to 0. As a result, it's equal to 3 over 2. If I apply upper limit, here is the again, so limit of integral is 0 to t. If I apply upper limit, so we have t minus 0, so we have t sine t. So we could find Laplace transform of the function.